Alright, for your notes, you can see there's lots of definitions. These will not be on your test on Thursday. These definitions will not be on your test on Thursday. They might be on your test like next week or the next week, but not Thursday. Okay? The first one is a system of equations. System of equations is two or more equations that have the same variable. So they have to have the same letters within the equations. And the next part is dependent on the solution of your equation. So a system is consistent if it has just at least one solution, one or more. And then if it doesn't have any solution at all, it's called inconsistent. Alright, if it's inconsistent, it can't be anything else. But if it's consistent, it can break down to be either independent or dependent. And that also depends on the solutions. So if it's exactly one solution, then it is, what do you think, independent or dependent? Independent, because it's by itself, just one. So that's if it has one solution, it's independent. And if it has infinite solutions, so a bunch of them, it's called dependent. So I want you to draw this diagram I'm about to draw so you can keep up with it. So it's either going to be inconsistent or consistent. If it's inconsistent, you can stop there, but if it's consistent, then you decide, is it going to be independent or dependent? I'm going to put a C right here so you can know that's inconsistent. Alright, so when we're solving by graphing, we have to graph two lines, and where do you think their solution is going to be? If I were to graph two lines, their solution would be where they cross. Good, the coordinate point where they cross. So for this first one, we know how to graph lines, but let's just review how to find slope and y-intercept. William, the slope on this one is going to be what? And how do you know that? Yes. And Madison, the y-intercept is going to be what?
0, 3.
Yes. This one's easy because it's in what form? Slope-intercept. So I would graph what first? The y-intercept at 3, and then tell me what to do from 3. Anybody? Good, right 2. I want you to draw at least 4 points. So keep going, down 1 over 2, down 1 over 2. And then you will need to draw your lines super straight because we'll need to know exactly where they cross. So if you don't have a ruler, let me know and I'll get you one. Go ahead and draw that line. You need one? And there might be one under your desk if you don't have one on your desk. Alright, the next one, my slope is what? Alright, -2. Good. Brianna, what's my y-intercept?
0, 6.
So I would start at 6. 1, 2, 3, 4, 5, 6. And Nicole, where do I go from here?
You go down to the right one.
Good. I'm going to do it a few times. And then go ahead and draw that line. So these do cross. What point do they cross at? 2, 2. I'm going to put a question mark. Because sometimes you might be off on your graph, or sometimes they might exactly not cross at that exact point. So we need to check our answers every time we solve by graphing. And how do we check this? Plug it into what? The first one only? Yes, has to work for both of them. So here's our check work. Our first equation is y equals, who is that? Oh. -1/2 x plus 3. So what would I plug in for y? 2. And for x? Alright, when I'm checking these, am I trying to like move numbers to the different side, or am I trying to solve for anything? No. All you're doing is evaluating each side to make sure they equal. So the 2 stays the same. What's negative 1/2 times 2? Y'all know this. Negative 1 plus 3. And is that going to give us 2? Yes. Alright, on the other one, y equals negative 2x plus 6. I plug in 2 for y, 2 for x. So again, this side I'm not changing. This side's going to be negative 4 plus 6. That's going to give us what? 2. Good. So it works. So this is our solution. 2, 2. And now we need to describe this system. So do you think it would be inconsistent or consistent? Consistent, why? It has one solution. Good, so it's consistent. And now, is it independent or dependent? Why? Very good. So you'll have to do this for all of them as well. Alright, I want you to do 2 on your own. Do 2 on your own. Let me know if you need help. Make sure you describe your system after you get done. Alright, now go ahead and compare your work to other people. Make sure your graphs are correct and you described it correctly. Alright, let's bring it in. So, Brandon, what was the slope of this first line? And what was the y-intercept? And Connor, what was the slope of this one?
1.
And the y-intercept?
0,4.
Good. So, these lines are what? How do we know that? Same slope, but they have different what? Y-intercepts. Good. So do I need to graph them for y'all? If they're parallel, where do they touch at? So what's the solution? No, that's a type of system. What's the actual solution? No solution. Good. No solution. That means that it's what type of system? And what about independent or dependent? Very good, because it's inconsistent. Any questions about that one? Alright, flip it over. We are going to do 3 together, then you're going to do 4 and 5 on your own. What's different about number 3? It's in what form? Standard. So, Simon, tell me how to find my slope from standard form. Y'all help him out. Good. So what's our A? -3. B? How do we find our y-intercept, Abigail Lund?
We put in 0 for x, so that just leaves 2y equals 12, and then we divide by 2 to get 6.
Very good.
6.
Everybody understand what she said? All right, Sierra, tell me how to set up for this slope.
1 over 2.
Good. Why did you say positive 1 over 2?
Negative a over b.
Yes, because it would be negative 1 over negative 2, which would make a positive. And what's my y-intercept going to be? And how'd you get that?
Divided by negative 2.
Yes, you said x is 0, divide by negative 2, you'll get negative 2. Everybody good with that? Go ahead and graph them on your own, and I'm going to graph them up here as well. All right, what's my solution? 4, 0. And now let's check it just to make sure. So I'll plug in 4 for x. If I'm plugging in 0 for y, do I even have to write the plus 2y? No. So it'd be 3 times 4 equals 12. That's going to work out. This next one I'll plug in 4. Again, I don't even have to plug in this because it'll cancel out when it's 0. Does 4 equal 4? Yes. So this is our solution. So Evan, what kind of system is this? Consistent and very good. Y'all have any questions so far? Alright, go ahead and do 4 and 5 on your own. make sure you describe your system, and then make sure that you check the point that you get. Make sure it's correct. Alright, if you are through, go ahead and compare your answers and your graphs to the people around you. Make sure y'all talk about, is the description correct? Inconsistent, consistent, and so on. Alright, I need two volunteers. Two volunteers. Be brave. Okay, Madison, I need one more. Alright, go ahead and do the first one. Caleb, you can do the second one after he gets done. So if you'll just show your work under there and explain how you got the slope, y-intercept, the graph, your answer, everything. Alright, Caleb's going to talk about the first one. Y'all check his work. If he messes up at any point, y'all just stop him politely and say, hey, this is what you need to do here. So start with that one. Tell us your slope and y-intercept, how you found it.
Okay, the slope of the first one is 2 over 1, and the y-intercept is 0, -3. And I figured that out because m, which is right here, 2, is the slope, and b, which is -3, is the y-intercept.
Okay. And how did you figure out the slope and y-intercept for the second one?
So I did negative a over b, which is -6 over -3, and that simplifies to 2.
Very good. And how did you find your y-intercept?
Plug 0 in for x, and 9 divided by -3 is -3.
Alright, so what happened when you graphed them?
So they're actually the same line. So it only looks like one line, but it's only one line, but both of them have the same slope and y-intercept as well.
Good. So where are these points, where are these lines touching at?
Everywhere.
Everywhere. So what's the actual answer? That's the type of system. Infinite solutions, right? They're touching everywhere. They're touching here, 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 forever. So make sure, go ahead, there's a pencil up there, right? Infinite solutions, that's the answer. So why is it consistent? Anybody? It's consistent if it has one or more solutions. Why is it dependent? Because it has more than one solution. Good. Any questions about Caleb's work? This is correct. All right. Thank you, Caleb. You can grab your pen with your sheet. All right. And now Madison's going to go over the next one. All right. So start with your slope and y-intercept. How'd you find that?
My slope for the first one was -3 over 1 with x, and then it's just plus 0 since there's no
Very good.
y-intercept there, so it'd be 0, 0. And then for the next one, it's 1 over 1, and then 0, -4.
Okay.
I graphed those at the point.
Is her graphing correctly? Is her graphs correct? Yes, no? Yes. Okay, so what's your solution?
1, -3.
And I see where you checked both of them. Did y'all get that? 1, -3? And did y'all check them and they work? So what type of system? Consistent. Tell me why it's consistent. Y'all help her out. Consistent has one or more. And why is it independent? There's only one solution. Good. Thank you. Any questions about those? So let's look back at the difference between number 2 on your paper, the one we worked together, and then number, I think it was 4. Because those are kind of weird, right? It was, one had no solution, one had infinite solutions. What's the difference? How would we know just by looking at our equations that it'd be no solution? They're parallel, but didn't the one on number 4 have the same slope? So what's the difference? Good, same slope. This one had what? Different y-intercepts. So different b's. This one had same slope and same y-intercept. Good. Everybody see the difference? Okay. I would write this down somewhere on your paper because you might have that on your test on Thursday. So same slope, different y-intercepts, that's going to be no solution. And same slope, same y-intercept would be infinite solutions. Alright, so you do have homework tonight. It's 4 problems. So this sheet is going to be your homework for the rest of the week. The graphing ones, there's only 4 of them. What I want you to do, work these out on your own. Try not to ask anybody for help, including me. Once you're done with these 4 problems, then you should have time to finish them in class. If you get all of them correct, you can pack up. Okay? You'll take one, pass back one. You can listen to music if you'd like. Just try not to ask your tutors for help. Yeah, you can use your notes. So make sure you find the solution and describe the system on these 4 problems. Oh, another thing. If you find like your y-intercept's like 12 on one of these and it doesn't fit on the graph, you've done it incorrectly. All your lines should fit on this graph. Let me know if you need help. Yes.